the review of what we have done in the previous example here. In the previous exercise, we've calculated per this loading type, 30 kilonewton, we've been calculating the reactant force in this portion is 50 kilonewtons. And again, look at this concept here. In this portion, the 50 magnitude of the force is 50 kilonewton. We simply divide that force by the cross-sectional area. And what we obtain is the average stress. And that the average stress basically meaning at every single point on the cross-section we have the same magnitude, which is determined by this calculation. And that is showing in our calculation here or repeated here. Okay, and again here we have utilized the ampere as our unit 159, and that is what we calculated in this. And that is the calculation for these portions. And again, one more time, you can repeat the same, repeat the process to calculate the stress in this portion. And the next slide, I'm going to talk about a little more about the unit of the stress. And here in the SI, the standard, the international standard unit, the Pascal, and again defined by Newton per meter, and that is the note we make here. And again, in most of the calculation, which means for most of the metallic materials, say if you can see, if I apply the loading just like this, okay, I hit the whiteboard, and in this loading around this local area, the whiteboard will easily experience a stress that can be as high as the certain value of the MPa. So here I can tell you in most of our daily exercise in terms of mechanical material, and MPa will be most of the units we've been experiencing, which means if we, in terms of the SI unit, and then that the magnitude, order of magnitude should be in the million times to the minus 10 to the 6. And GPa, again, G means giga. Okay, so if you have the larger the calculation, you might replace 10 to the 9 PA by GPa. Okay, the G means giga. On the other side, we have the English unit. So that means in parallel to this SI unit, the force in terms of the newtons in the US unit is using pounds. Okay, just like our example here. So here I use the example is pounds per inch. So basically here in our definition we define this is the PSI, pound per PSI, pounds per square inch. Okay, so that is the definition for this one. Again, pounds per inch square, pounds per inch square or square inch, and that is the unit here. Okay, and one more time, most of our calculation, and again, once I use my elbow to hit the whiteboard, just like this, and then easily the result would be, say, at this scale, so 10,000, couple value of the 1,000 psi. So most of the time, to save our writing, we can write it out as this 1,000 psi. Basically, you can use the KSI. K means 1,000, and here K should be combined with KPSI, but people drop off P just using KSI. Okay, so that is for the units here. And we stop here.